It is very common that when you import a data set into Python that you'll want to take a subset of that data to do some further analysis. Oftentimes, there might be things at the beginning or end of the data set that you need to cut out, or if it's a periodic data set, but you're trying to just fit a feature that is in one period, which is our example in lab, it's another instance. So there's two ways you can do that. One is based on the indices. So arrays are like lists of numbers, and so you can pick out a subset of indices on those arrays and take a subset. The other is based on a condition, and I think that's the more generally useful one. But I'll first show you indices, and then you can kind of see why the condition is better. So let's take a data set like this data set here. It is RC decay, and is RC circuit that's being driven by a square wave. I can add some grid lines to it. That often helps, at least if you're trying to figure out exactly what time particular events happen. So suppose I actually wanted to get this decay that runs from like 0 seconds out to 1 millisecond. How would I do that? It's a little bit convoluted. Like the first thing I might do is figure out what's the length of the array. So I'm going to print that out. And so that's 3128. So what I'm going to figure out now is sort of like there's the T0 index, and that's roughly halfway to the end of the data set because it happens right in the middle. So I'm going to call that my T0, kind of that's my start time. And so that's going to be this max index divided by 2. And I need to convert that to an integer so that I can use it as an array index. So it might end up having a decimal point or something. And then the stop time, I'm going to do like 1 millisecond. And that's like 3/4 of the way through this data set. So in fact, what I can do is I can do something like 3 divided by 4 times max index. And I got to convert it to an integer because in general that may not be an integer. So it's going to give me the integer closest to 1 millisecond. Basically, that's what we're getting. So then, if I want to take a subset of t-values, I can have t sub, and that can be equal to the original t, but now I'm going to go from the index, the start index, to the to the t1 index, and I'm going to have, say, I'll do the same for channel 1. Oh, and in fact, those are not supposed to be commas. Those are supposed to be colons. And this will grab all of the values from T array and channel 1 array that have that span of indices. So that colon, kind of like in a spreadsheet when you use the colon and it means take anything in this range. That's what it does. So I'm not going to, it's the exact same for channel 2. But now what I could do is I could do a plt.plot of T sub in channel 1 sub. And notice this goes from 0 seconds out to about 1 millisecond. And so that is kind of option 1 for using array indices. It worked out pretty good here because I had exactly 4 periods, and so it was easy to say I want to go from roughly half the data set to 3/4 of the data set. A lot of times you're going to have a signal where it's not so easy. So the other option is using a condition. So what I'd like to do is to make a condition, which is an array of true or false values. And the condition is going to be composed of 2 separate conditions. Condition 1 is going to be that the time, and so t is an array of values, but the t has to be greater than 0. Condition 2 is that t has to be less than 0.01. So 1 millisecond. So those are going to be the 2 conditions. And I can just give you a little sense of what condition 1 looks like. I'm not going to print out the whole thing, but I'll say print the first 5 elements. right? So initially, all the t-values are negative at the start of the data set, and so it's just false, false, false. But if we, pick something around, say like 3100 to 3105, right, those are all true, 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 because at the end of the data set, time is positive. Okay, so those are the two conditions. I want to combine those into one single condition, and the way you do that is there is a function that will kind of go element by element through a pair of arrays and apply a logical operator. So in this case, we want to do logical and. So there's a couple different logical and, logical not, logical or, logical exclusive or, but we want logical and. And we want to take the logical and of both conditions. So I only want to do this when both are true. So I want a condition that represents the t-values between 0 and 1 millisecond. And just in case you're wondering, the length of condition is exactly the same as the t-values, but it happens to only be true for that subset of values that represent between 0 and 1. So now, if we were to find a new way to write t sub and channel 1 sub, right, we can do that by taking the original t-values, and we can, rather than giving it a set of arrays, a set of array indices, we can give it a condition. So that condition acts as a substitute for array, for a set of array indices. And now I can do the plt.plot of t sub channel 1 sub, and that's what we get. Right, so this has the advantage of being far more flexible, right? If you wanted to shift this in a little bit, so like rather than going out to 1 millisecond, maybe I'm like, all right, there's that little start of the next oscillation right at 1 millisecond, so I want to trim it just by a little bit. So why not take it out to 9e minus 4, and then I trimmed off that last little bit, and there I have it. And so that's the kind of data set that then you can fit to a function. Like in this case, it's supposed to be an exponential decay. So you don't want to fit multiple oscillations, because the fit function can at most only fit one rising exponential or one decaying exponential. You can't fit both of those. And so at the same time, so you have to just pick out one or the other and then fit it.